I'm going to give you some examples that get fairly complicated. Let's simplify 64 x to the negative 1/4 y to the 5th all raised to the negative 1/3 power times 25 x to the negative 1/2 y raised to the 1/2 power. Well, the first thing I'd want to do is to work inside symbols of inclusion. Now, I cannot really simplify inside symbols of inclusion because my bases are different. I have a 64, an x, and a y, a 25, an x, and a y here. So I cannot work inside the symbols of inclusion. My second step in the strategy is to apply the exponents outside the symbols of inclusion to each of the bases inside. So the negative 1/3 would go with the 64. The negative 1/3 would go with x to the negative 1/4. The negative 1/3 would go with y to the 5th. The 1/2 would go with 25. The 1/2 would go to x to the negative 1/2. And the 1/2 would go with y. So this is what I've written down. And I hope you can see it all on the screen because it really extends it. But the negative 1/3 goes with the 64. The negative 1/3 goes with x to the negative 1/4. And the negative 1/3 goes with y to the 5th. The 1/2 goes with 25. The 1/2 goes with x to the negative 1/2. And the 1/2 goes with y. Now the next step in your strategy is to raise powers to powers. So I do that, trying to keep moving it, keep everything in the screen. I don't give you the whole answer yet. So we want to raise powers to powers by keeping the base and multiplying the exponents. Now I'm leaving 64 to the negative 1/3 because there's nothing to do there. To raise powers to powers, I keep the base and multiply the exponents. A negative times a negative is positive. 1 times 1 is 1. 4 times 3 is 12. Again, I'm raising a power to a power, so I keep the base and I multiply the exponents. Now that's understood to be 5/1. So I say 5 times negative 1 is negative 5. 1 times 3 is 3. So I raise a power to a power. I keep the base, multiply the exponents. I have 25 to the 1/2. And here I'm raising a power to a power again. To raise a power to a power, keep the base, multiply the exponents. A negative 1 times 1 is a negative 1. 2 times 2 is 4. And then we have y to the 1/2. The next step in my strategy says to multiply and divide powers that have the same base. The x and the x have the x to the 1/12 and the x to the negative 1/4 have the same base. The y to the negative 5/3 and y to the 1/2 have the same base. So what I want to do is to multiply those powers that have the same base. To multiply powers having the same base, you keep the base and add the exponents. I'm also group and put the 64 to the negative 1/3, the 25 to the 1/2 together. So we have 64 to the negative 1/3, 25 to the 1/2. I have x to the 1/12 times x to the negative 1/4, the y to the negative 5/3 times y to the 1/2. So I just put things together. And now to multiply those powers having the same base, I'm going to keep the base and add the exponents. So just bring down the 64 to the negative 1/3, bring down 25 to the 1/2, and keep the base, add the exponents. 1/12 plus the negative 1/4. Keep the base, add the exponents. Negative 5/3 plus 1/2. In order to add the exponents, I need a common denominator. The common denominator between 12 and 4 is 12. 12 goes into 12 one time. 1 times 1 is 1. 4 goes into 12 three times. 3 times negative 1 is negative 3. The common denominator between 3 and 2 is 6. 3 goes into 6 two times. 2 times negative 5 is negative 10. 2 goes into 6 three times. 3 times 1 is 3. And I keep the denominators and add the numerators. So we have the 64 to the negative 1/3, 25 to the 1/2, x to the negative 2/12, y to the negative 7/6. 1 plus a negative 3 is negative 2. Negative 10 plus 3 is negative 7th. Finally, I put the answers in good form, remembering that negative exponents tells me to take the reciprocal. So, we have 25 to the 1/2. Now notice that 64 has a negative exponent. So I take the reciprocal and have 64 to the 1/3. A negative exponent tells me to move it from the numerator to the denominator. You never work with the exponent except just leave the negative off once you take the reciprocal. 25 has a positive exponent, so I'll leave it. X has a negative exponent, so I take x to the denominator. Y has a negative exponent, so I take y to the denominator. Finally, I evaluate the numbers. 25 to the 1/2 is the same as the square root of 25, which is 5. 64 to the 1/3 is the same as the cube root of 64, which is 4. So my final answer will be 5 divided by 4, x to the 1/6, y to the 7/6. Let's look at one more before I give you a couple of the harder ones for you to play with. Let's simplify 4x to the negative 1/2 divided by 8x to the 1/3, all raised to the negative 6 power. Well, we need to work inside symbols of inclusion first. So the first step is to work inside symbols of inclusion. I can reduce the 4/8 to 1/2, and to divide powers to have the same base, I keep the base and subtract the exponents. So I would have 1/2 x to the negative 1/2 subtract 1/3, all raised to the negative 6 power. So I just reduce the 4/8 to 1/2. I keep the base and subtract the exponents, the top exponent minus the bottom exponent. Now to do this, I need a common denominator. The common denominator between 2 and 3 is 6. So I have 1/2 x to the negative 3/6 minus 2/6 raised to the negative 6 power. Once I get the common denominator, I keep the denominator and subtract the numerators to get 1/2 x to the negative 5/6, all raised to the negative 6 power. Now all this is just working inside symbols of inclusion. Now I've done everything inside symbols of inclusion that can be done. So I apply the exponent outside the parentheses to each of the factors inside. So I have 1/2 to the negative 6 times x to the negative 5/6 to the negative 6. A negative exponent tells me to take the reciprocal. So if I take the reciprocal of 1/2, I have 2. So a negative exponent says take the reciprocal of the base. The base is negative 1/2. The base is 1/2. The reciprocal of 1/2 is 2. So I have 2 to the 6th. And to raise a power to a power, I multiply the exponents. So doing that multiplying, a negative times a negative is positive. So I'd have a positive 30 divided by 6, which is 5. Just one more step now. To do 2 to the 6th, that means 2 times 2 times 2 times 2 times 2 times 2 until you've used 2 as a factor 6 times. And I get 64 x to the 5th as the answer. Since these problems are so long, I'm just going to give you one problem as your exercise. But it is a doozy. Simplify 2x to the negative 1/3 divided by 4x to the 1/2, all raised to the negative 2 power, times 8x to the 1/2 raised to the negative 1/3 power. As soon as you get the problem copied down, stop the tape, work the problem, and then restart the tape to check your answer. Here's your answer. 2x to the 3/2. If you disagree with that answer, be sure to check with someone. This completes tape 120.